So, in the previous class we were talking about this chemical fabrication method of making metal powders, and under these categories, as I said, we have different processes which are listed here, and we talked about this gas solid reduction reaction by which you can make metal powders by reducing a metal oxide in the presence of a reducing gas like carbon monoxide or hydrogen at a particular temperature. We had also seen the thermodynamics and the kinetics of this reduction reaction, and the how this whole process of or this reduction reaction depends on the temperature, that also we have discussed. Now, today let us look at the other chemical methods of making metal powders. So, these powders can be also precipitated from a liquid. So, this is a wet chemical method of making these powders, wherein you have these metal ions in a solution, and then you precipitate it like how you do titration. So, you have a titration kind of method which is followed here to precipitate these metal ions from a solution in terms of these metal powders. Okay. So, you start with these metal salts which can be easily dissolved in water. For example, this metal nitrate, chloride or sulfates, this kind of metal salts can easily be dissolved in water. And with the help of a precipitating agent, this powder is precipitated from the solution. This is an example of making silver powder using this silver nitrate in a solution, in which you have this second compound, and with the help of this these silver ions which are there in the solution is precipitated as solid silver or silver powder. Okay. And if necessary, these metallic ions can be also reacted with the hydrogen to form the metallic precipitates, right. So, once this precipitate is formed, this will be filtered, and then it will be washed properly again with water, so that all other residues are removed from it, and only this metal powder remains, and that after filtering this will be dried, and after drying this will be collected as metal powders. And the powder characteristics that you have from this kind of powder, that can be controlled by controlling the process parameters like the concentration of the solution and so on. And the powders which are generated in this method are in the range of 1 micrometer and are of high purity, but the flow and packing characteristics of such powder are poor. This process can also be used to make composite powder. That means, you can combine two different materials into one, or you can also make an alloy. That means, you add another metal into you add a second metal into the first metal powder that you have and make alloyed powders. So, the process for making these composite or alloyed powders is known as co-precipitation. That means, two different materials are co-precipitated together to either make a composite or make an alloy. Okay. So, that means, the starting powder or the starting material will have the metal salts of both the metals that are to be combined either into a composite or into an alloy, right. So, you take the salts of both the metals and then make a solution of that and with the help of precipitating agent, again like what we have done in this case, this powder is co-precipitated either as alloy powder or composite powder. So, when you have two different materials combined into one phase is used to nucleate the precipitation reaction. For example, if this kind of oxide or carbide materials are coated with metal. So, this metal coating can be precipitated over these oxides or carbide surface. So, that surface would actually act as the nucleation site for this metal to precipitate. So, this metal will precipitate over this surface and then you can get a coating of this metal over this kind of materials. Okay. And the precipitation technique is also useful for making powders of reactive metals such as zirconium and titanium. So, while we are talking about precipitation from a liquid, let me also give you some some fundamental or some basic idea about this particular process by taking an example. So, let us see generally how this process works. As we have seen, you start with a liquid which contains the metal ions, and in case of co-precipitation technique, what you do, you have more than one metal because you want to combine them into one single material. So, this is an example of the same process of co-precipitation as you can see over here. So, here I have taken an example of yttrium being added to zirconium. Okay. So, there are two precursors, one for the zirconium and the other for the yttrium in terms of their chlorides, which are available as metal salts. So, these are metal chlorides, zirconium oxychloride and yttrium chloride. Okay. So, then you make a solution out of this by adding these two into water and dissolve it, and you need to make sure that the solution is basic, right. So, you need to adjust the pH in order to precipitate these metals from the solution. So, what happens in order to adjust this solution to a basic solution, you will have to add ammonium hydroxide or sodium hydroxide, which will make sure that this zirconium and yttrium ions are hydrolyzed. So, they will be forming their hydroxides as you can see in the solution. Okay. So, after you add the base and make it basic, you have these metal ions in terms of their hydroxides in the solution, right. And then once you do that and hydrolyze it, then you can get the precipitate, wherein both zirconium and yttrium ions will co-precipitate together. Okay. So, this is why the process itself is known as co-precipitation, because there are two or more metal ions which are precipitating together, right. So, once this is precipitated, the precipitate is collected and then it is washed and dried. Okay. And for many materials like oxides, you will have to then heat it to some higher temperature, so that you can convert these hydroxides into oxides. So, that is kind of more suitable, or that is the process which is actually adapted for making ceramic powders like the oxides. In this case, for example, you have this yttrium zirconium oxide, which is obtained from these hydroxides, which are precipitated from the solution by heating it, which is known as calcination. Calcination is nothing but heating this precipitate at some higher temperature, and once you do that, these hydroxides will be converted into oxides. Okay. So, this is how the whole process goes, as we have seen. Starting from a solution, you obtain the precipitate and then you can wash it and dry it to get the powder. And precipitation can also be obtained from a solution by actually atomizing it into smaller droplets inside a chamber, and then you heat it inside the chamber to get the precipitate in terms of a powder. Okay. So, this process is known as spray pyrolysis, because as I said, you start with a spray and then you pyrolyze, or you heat it inside a heated chamber, where it goes through the thermal decomposition process, and then finally, you get these metal ions which is present which are present in the solution precipitated at the end of the chamber, which can be collected in a collection chamber. So, the way the process goes is, you have this solution which contains the metal ions, and this the solution is first sprayed and then it is sent through a heated chamber, as I said. So, this spray can be created by an atomizer, as you can see over here, right. So, as you send it to this chamber, you have a nozzle over here and you atomize it, which can be done, for example, by high velocity gas jets, and sometime the aerosols are first made in a separate unit, and the spray of that aerosol is then sent to this chamber, where this solution or this spray is heated up, and the powder is collected at the end in this collection chamber. And there are at times the powder which is precipitated after going through the thermal decomposition process can also be collected on a preheated substrate, which is kept over here, as you can see. Okay. So, once the pyrolysis happens inside the chamber, as it is heated up, the particles are generated, and as I said, this can be either collected in the collection chamber or deposited on a preheated substrate, and then it can be coated on this substrate. And in that case, this particular process of spray pyrolysis can also be used as a coating technique, wherein you keep your substrate over here and coat it with this powder, which is generated by this process. Okay. So, this is not only a useful process for making powder, but this can also be used for getting coating on a particular surface. And in case of metal powders, an inert atmosphere is needed inside this chamber. so that the metal can be prevented from oxidation, right. Otherwise, there are chances that the powder will be oxidized because this whole chamber is heated up, and if there is oxygen present inside the chamber, if it is not evacuated or if it is not flushed with an inert gas, then there are chances that the metal powder will be oxidized. Okay. In fact, in many cases after collecting these metal powders, they are actually subjected to a reduction process in the presence of hydrogen or other reducing gases, so that if there are any oxides which might have formed inside the chamber during the process, those oxides can be reduced and you can obtain pure metal powders. Okay. And often what is done is this heating is done in stages, meaning this chamber has different stages of heating, starting from top and going to the actual thermal decomposition or the pyrolysis zone, where the temperature is higher compared to the temperature when the solution actually enters the chamber. Okay. So, it is gradually heated up first to a lower degree, where it is actually a kind of drying process, and then the temperature is gradually increased. So, you can have 2 or 3 stage heating inside this chamber, so that the solution goes through a gradual heating instead of a single step heating, right. So, that is also done often in order to make sure that the thermal decomposition is gradual and you allow enough time for this solution to get converted into powder particles, right. So, this is how the whole process of spray pyrolysis is done to obtain powders. Then there are other precipitation routes like the hydrometallurgical precipitation process, which involves a metal dissolved in a solution to form the ion complexes which are then precipitated. Okay. So, what is done in that case is an easily soluble compound of the metal is dissolved in a solution to have these metal ions, which will be then precipitated from the solution. For example, copper sulphate can be used to make copper powders. So, what is done here is copper sulphate is first dissolved in a solution, and then it is reacted with hydrogen at 130 degrees Celsius and 3 megapascal pressure to produce solid copper as powder, okay, or as the precipitate, which comes out from the solution when it is reacted with hydrogen. Okay. And in this case sulfuric acid is generated as the byproduct. Okay. Then the hydrometallurgical route can also be used to make refractory metal powders, for example, tungsten, tantalum, those kind of refractory metals can be produced by this process. Here is an example of making tantalum powder by this hydrometallurgical route. So, in this case what is done is a halide salt that contains the metal is used to make a solution first, and then it is reduced by sodium. Okay. So, in this example this salt K2TaF7 contains tantalum, and it is reduced by sodium to release the tantalum from this particular compound. Okay. So, once the solution is formed, molten sodium is added into the solution under some inert gas atmosphere to start the reduction reaction. Okay. And once the reaction is completed, the reacted mass, which actually comes out as a cake, will contain this tantalum, and in order to release this tantalum from the cake, it is processed through a series of leaching steps, series of washing steps to obtain pure tantalum as the powder. Okay. So, that is the final product once it is reduced and then washed out thoroughly, tantalum is obtained as the powder. Okay. So, this is a process which can also be used to make powders of refractory metals. This precipitation can also be obtained from a gas like what we had from a liquid. So, in this case, like how the liquid contained the metal which is to be obtained as powder, in this case the gas will contain the metal. For example, this copper chloride, this is a gaseous compound of copper. Okay. So, if this can be reduced by a reducing gas like hydrogen, then copper can be released. Okay. But again this has to be done at a high temperature like 1000 degrees Celsius. So, if this gas mixture of copper chloride and hydrogen is heated at such temperature, then hydrogen will reduce this and copper will be released as solid copper or copper powder, and HCl is the byproduct. So, here this kind of powders can be formed without melting or contact with any crucible, and the characteristics of powder are generally spongy, and in terms of the shape they are spherical and polycrystalline in nature, and this particular method can be used for making composite powder as well, or can also be used for refractory coatings. Okay. If it can be precipitated over another surface like what we have seen in case of the precipitation from liquid. Here also this can be precipitated over a surface, and this precipitate can get coated over that surface. So, you can get coatings, for example, like refractory coating on another surface. And finally, this is another chemical method of powder fabrication. This is using a solid state reaction in which a solid material is the starting material which is reacted with another solid to make the final powder. Okay. And this is particularly useful for highly alloyed or intermediate compounds with precise stoichiometric ratio such as this iron chloride or this NiTi or this titanium sulphide. So, this kind of intermediate compounds, as you can see, they have a particular ratio between these two atoms. For example, in this case iron chloride, this is 3:1, in this case it is 1:1, and in this case this is 3:5. So, they have a particular very precise stoichiometric ratios, and these solid state reactions are a useful synthesis method for making powders of such materials. Okay. And the process involves mixing of these constituent powders in that particular ratio in a loosely packed bed, which is then ignited, and the reaction proceeds in a self propagating manner. Okay. So, that means once you ignite and the reaction is started, the reaction will propagate by itself, because it is a exothermic process. So, the heat which is generated from the process, that will actually help the reaction to proceed further. Okay. This is an example where nickel and aluminum is reacted in solid form, and in the reaction this nickel aluminide is generated and heat is produced, as I said, which is helpful in making this reaction self sustaining or self propagating. Okay. So, once the nickel and aluminum reaction starts, the reaction goes spontaneously, and this is very similar to an explosion reaction that happens between hydrogen and oxygen, which produces water. Okay. But if the reaction is not controlled, if the reaction is uncontrolled, then it can generate a high amount of heat, which may be sufficient to even melt the reaction product or the powder which is obtained. Okay. So, therefore, if the melting has to be prevented, it is also necessary to control the reaction, so that the temperature does not rise to a very high extent and melting can be prevented. Therefore, it is necessary to extract the heat, right. If you want to prevent this melting and prevent this overheating, then the heat which is generated has to be continuously extracted from this reaction. And there are many variants of this process, and this kind of method is mostly used for ceramic powders rather than metal powders, because as you can see here from the reaction itself, two metal powders are actually reacting to each other to make a ceramic or a intermetallic compound. Okay. So, that is why it is rather more suitable for making ceramic powders, right. So, with this we come to the end of this particular class. Thank you for your attention.